Okay, so again, let's talk about the quiz now. Just let you know, at the end we'll talk about the exam. So kind of hold off your exam questions until last part when I start talking about it. And then if you have questions about what I'm talking about, or if I didn't say something, you can ask me. But for now, let's hold off on all questions about the exam. That'll come at the last half of what we're doing today. But anything else, please ask questions about. So now let me show you the quiz. Okay, so here is the quiz, and let's take a look at it. So first thing, question 1. Suppose that the weight of a medium-sized apple is uniformly distributed between 80 and 110 grams. You must show your work. Okay, part A. Okay, even before we get to part A, what we need to do is we need to find the height of the rectangle. So because it's not easy to draw a rectangle, I'm just going to say there's a rectangle with base from 80 to 110 and height h. Okay, what do I know about the area of this full rectangle? What's the area of the full rectangle? Yeah, it always equals 1. And then hopefully remember the area formula is base times height. So we can say is the base, and the base is going to be 110 minus 80 times the height, which I'll just call h, is equal to 1. So that's the same thing. 110 minus 80 is 30 times h equals 1. Divide by 30 and you get h equals 1 over 30. Any questions just on the kind of preliminary part of this question? And that is, how do you get the height of this rectangle? Because we're going to need that for A and B, actually. Okay, so now what we need to do is do part A. So right now I just got the height of the rectangle is 1 over 30, right? Because we have to have the base times the height is equal to 1, and the base was 30. I'm not sure where the 12 came in. Maybe you're doing part A. I'm just doing the prelim stuff. So I'm not sure if you have a question about that or not, but let me know. Okay, so the height is definitely 1 over 30 because the base is 30. So the height must be 1 over 30 to make it equal to 1 when you multiply. Does that make sense? Okay. So now what I need to do is we were saying now Kamal randomly selected a medium-sized apple. Find the probability that it will be larger than 103 grams. So now we have a rectangle. From 103, and larger means on the right-hand side, the high side, to, actually, I guess it's say base. With base from 103 to the high side, and the high side was 110. And height, 1 over 30, because that was the height we found in the prelim stuff. Okay, well, how do we find the probability? The probability is the area, and how do I find the area? It's kind of the formula for this, or the formula for this problem, actually. So our area, probability that x is greater than 103, is equal to the area. And the area is the base times the height. Have I lost anyone yet? Any questions? And that is equal to the base. Well, the base is going to be 110 minus 103. So it's always the right minus the left. The height is 1 over 30. That was the whole point of doing the prelim stuff. And then 110 minus 103 is 7, and you get 7 over 30. And there's our probability. Any questions at all on this example? Any questions on this part A? Okay, let's go part B. So part B is, what is the 35th percentile for the medium-sized apples? So now the 35th percentile, what does that mean? What does it mean to say 35th percentile? See if someone can chime in, or you can say it or put in the chat. What does it mean to say 35th percentile? Hopefully you can all type it in. So what's it mean to say 35th percentile? Any thoughts? Hopefully you can all hear me. Yeah, so lowest 35%. Let me write down, that's kind of the right answer, but I think it's easier to go to write it in the statistics formula. And that is the probability of being less than X, so less than some value, is equal to 0.35. I think it's be easier to talk about it that way, because that's what the percentile means. Now, probabilities are area. So what we have now is, we know the area is equal to 0.35, but that is equal to the base times the height. The base is going to be X minus 80. Because the right-hand side of the rectangle is at X, which we don't know. The left-hand side is 80, and the height is 1 over 30. And let me just rewrite equals 0.35. Okay, so now what we want to do is we need to find X. So what can we do to both sides? So what do we do on the left and right? Yeah, we multiply by 30. Good. So we get X minus 80 is equal to 0.35 times 30. And you can use a calculator, or you can just say that's 10.5, if you can do it in your head. Any questions on that? And now we want to get X by itself. So what is X equal to? Yeah, 90.5. And that's our 35th percentile. Any questions at all on part B? Any questions on part B? Okay, let's move on to question 2. Okay. I wonder if it said this for you. I fixed it when I said about an hour ago, I saw that it had a hat instead of that. Did you see hat or that when you did it? Just curious, because I actually fixed it and hit save. But it may just be remembering my old one. Okay, so, oh good, so it did say that, okay. For some reason, it didn't fix for my preview thing. So suppose that the time it takes to charge a Tesla Model 3 is uniformly distributed between 5 and 8 hours, okay? Don't quote me on this. I did look it up and it did say that the average, I think, was 6.5 or something like that. So then I made up the 5 and 8, but we'll do what we can. Okay, so suppose that today it took Lydia 5.1 hours to charge her Tesla Model 3 today. Use z-scores to determine whether 5.1 is an outlier. Be sure to show your work. So what we need to do is we need to find the z-score, because I said use z-score for 5.1. Okay, well, who remembers the formula for the z-score? All right, z equal. Who remembers the formula for the z-score? Y'all jumping in? Okay. So that's going to be x minus mu divided by sigma. Any questions on the formula for the z-score? Okay, that was given, that was a chapter 2 formula, but we've used it a bunch of times. So you want to know that one. So we need to find mu and sigma. So when you have a uniformly distributed variable, and in fact, let's write that down. We can say x tilde u 5, 8, 5, 8. And that means x is uniformly distributed with a low of 5 and a high of 8. And when you have that, what you do to find the mean is you take the average of those numbers. That's going to be 5 plus 8 over 2. What's 5 plus 8 over 2? Close, 6.5. 5 and 8 is 13. Divide by 2, you get 6.5. Okay, and you are allowed to use a calculator, by the way. There'll be a built-in calculator on Thursday for you. Okay, and sigma is, we have a formula for that, and I think what I need to do is I need to put it, it's too fancy to type it, so I'm going to use the math page editor. So that is going to be, if you remember, that is going to be B minus A. One more time. Parenthesis, B minus A squared divided by 12. Any questions on that formula? So that is the square root. And remember, we went from 5 to 8. So that's going to be the square root of 8 minus 5 squared divided by 12. Okay, now I don't expect you to do that in your head. Okay, but if you've done trigonometry, actually, you can do it in your head, but only if you really remember your trig. So I'm not going to. I'm going to do 8 minus 5 in my head. I'm going to do a little bit of it. 8 minus 5 is 3. I can do that. It's less typing if you do that. And 3 squared is 9. So it's the square root of 9 over 12. Then it's going to type SQRT of 9 over 12. There we go. And that's 0.866. It's also root 3 over 2. So that's 0. .866. Any questions at all so far? Okay. Now we put it into the formula, and we can say that we can say that z is equal to, well, the x we found out was 5.1 because that's given. We want to see if 5.1 is an outlier. So Z is 5.1 minus 5 divided by 0.866. Okay, we can drop that in a calculator. I use the convenient Google calculator. And it gives me I'm sorry, it's not minus 5, it's minus, oops, I made a little mistake there. It's 5.1 minus 6.5. We can put that in the calculator. And you get negative 1.62-ish. Okay, so what's the answer? What do we say? Our question again was use z-scores to determine whether 5.1 is an outlier. Was 5.1 an outlier? What do you think? Yeah, no, and the reason is that is actually greater than -2. Remember, -2 is that bound that we look at to decide whether you have an outlier. And if you are to the left of -2, you're an outlier, or to the right of 2. So therefore, 5.1 was not an outlier. Any questions at all on question 2? Any questions? Okay. So I try not to give you really completely out of the ordinary problems. I try to give you problems that we've done before or combining two things that we've done before. So the first one was exactly a standard question and the other combined chapter 2 and 4. But not some abstract thing. You just got to use the right formulas. Any questions at all on this example? Okay, let's go to what we're doing today. So we've talked about the quiz. Now I want to talk about the normal distribution. We've actually mentioned it already, but haven't gotten into details. I will tell you, and right now you just have to trust me, the normal distribution is the most important distribution of any distribution there is in statistics by far. Okay, even though the uniform distribution is much easier because it's just a flat thing, you can take areas of rectangles, that's wonderful. It turns out this normal distribution is much, much more important. Okay, and this is one of those you're going to trust me, and next week we're going to have a theorem that tells you why. But this week we're just going to learn about it. We're going to check it out. Any questions on kind of the idea that this is really, really important? I want to also mention that unlike the uniform distribution, which is just a flat line, horizontal line, very easy equation. This is y equals a constant, whatever that h is. The normal distribution is very complex. Okay, in fact, the equation, I'm going to say it real fast because if I say it real fast, it means you're not responsible. But it's so important, I figure I should say it. And that's 1/2 to 2 pi sigma times e to the negative x minus mu quantity squared all over sigma squared. Okay, it's messy. So if you understood that, I'll be surprised. So it's a really messy, ugly formula that we're not going to get into. What you are responsible for is knowing the shape. So, and that was actually, we talked about that already in chapter 2. So what is the shape of a normal distribution? Okay, so I have I see a question. Do normal distributions have smaller standard deviations? That's a very good question, and it turns out normal distributions could have any standard deviation. Okay, so, and uniform distributions also could have any standard deviation, right? If A and B are really far apart, you get a big standard deviation, right? Because then B minus A is going to be big. Same thing with normal distribution. you can have a standard deviation of 1,000,000 and have a normal distribution. You could have a standard deviation of 0.01 and have a normal distribution. That actually is not, it could be anything. Okay, in fact, we call the standard deviation and the mean parameters. And I'll mention those in a bit more. Okay, but what is the shape of the normal distribution? That's something we've already seen. Just in a few words, how do you talk about the shape? Yeah, so kind of most of you have a good view of kind of what a bell curve looks like. Bell curve is just another name for the normal distribution. Okay, so that's kind of the shape. I'm going to give you some statistics words. It's symmetric. It's unimodal. Remember those words? So it's symmetric, it's unimodal, and bell-shaped. So it's a normal distribution. Any questions, at least on the words for the shape, before we look at the picture? Okay, actually, one more thing before we look at the picture. Who remembers, and hopefully you put it in your project, okay, especially if you had one, is what does the empirical rule say if you have a normal distribution? What were the key numbers? Yeah, 68, 95, and 99.7. And actually 1, 2, and 3, those are the easier numbers. So one standard deviation away, or a z-score of 1, or -1 in between, is 68% of the data. And then 2 is 95, and 3 is 99.7. Okay, now we can put this in a picture. And they've done a nice job. I copied and pasted this from Google, obviously. Google's got everything. So I tend to use Google, and this was a nice one. So you'll notice they actually have, in this picture, 2 ways of looking at it. One is we have 0, 1, -1, 2, -2, 3, -3. And we could say between -1 and 1, you have 68. Don't worry about the 0.2. We're just going to keep it at 68%. Something I didn't love about the picture is I like rounding it to 1 decimal. It's good enough for that. And 95% for -2 to 2, and 99.7% from -3 to 3. So notice that between -3 and 3 is almost all the data, right? 99.7% is almost everything. Very little left. Okay, if you're not talking about what's called the standard normal, if you just have some general normal, then our mean, mu, is always the median. Median, remember, is the center. So mu is right in the center of the normal distribution. Any questions on that? And then you go out 1 sigma, 2 sigma, 3 sigma. Okay, so again, if you have just general standard deviation, you put a sigma there. Any questions at all? Any questions at all about the picture of a normal distribution? Okay, the shape is always exactly the same. The scale can change. Okay, the scale can change. Sometimes the, you're going from, the mean could be 100 instead of 0. And that just means it gets shifted over to the right. Standard deviation could be tiny, and that means it's tall and narrow. But it's still bell-shaped, but it's tall and narrow bell-shaped. Any questions at all on the picture? All right, so now let's do some problems. And we're going to start out by doing some without using a calculator, okay, or a computer, I'm going to say. And we're going to say, suppose that Z follows a standard normal distribution. Standard normal just means that Z tilde n 0, 1. So that means that we have a normal distribution with the mean of 0 and the standard deviation 1. Okay, and that's our Z. All right, let's see if you can answer this, because this part A is really easy. Find the probability that Z is between -1 and 1. The hint is this is easy. You should just say the answer. There's no work to do. Yeah, yeah. You're really close, but probabilities can't be greater than 1. I think you have the right idea. Yeah, 0.68. Okay, so that is just, and let me write it out as P -1 less than Z less than 1 is equal to 0.68. Any questions at all on this example? Okay, the next one's a bit harder. Let's find the probability that Z is less than 3. Okay, this one's not immediate. It's not just going to be one of those numbers that we already saw. Okay, that's not going to work. Instead, we have to do some drawing. Is the easiest way to do this. So the probability that Z is less than 3. So let me do some drawing. And I'll do my best on the drawing. So I do that. Now let's draw a scribble. And I'll do my best on the Z. Okay, again, don't expect me to be a perfect artist. That has never been my skill, but that's supposed to be normal. And the idea here is we want to find the probability that we're less than 3. So I'm going to draw some marks. I'm going to draw that one. Then I'm going to draw this one. And let's put some letters in. So that's 0. That's 3. And it turns out, whenever you have a normal curve that you want to do by hand, you want to draw the symmetric piece. So I'm going to also draw -3, because all we've got is between 3 and -3. We don't know 3. Yeah, I'm seeing an answer, but let's take a look. Okay, there's going to be some calculation we have to do. So I'm going to make that a -3. Now we know between 3 and -3, that one we know. What is the area? Let me scribble it. All that stuff between 3 and -3. What's that area? We'll get there. We'll get there. It's a good question. Why not below -3? The answer is because we don't know it yet. So right now, I'm just going to draw what I know. And I know between 3 and -3 and 3, because that was actually given in that first picture. Do you remember the number? It was an important number. Scroll up in the chat box, you'll see it. Yeah, 0.997. So we'll get that, and that's the thing. We also need to find out the area to the left of -3, because that's more of our picture. So we need to find that also. The first diagram had all kinds of numbers, but all we're going to use is the 68, 95, and 997. Okay, otherwise there's too many numbers to read. In fact, they call it the empirical rule. It's often called the 68, 95, 99, 7 rule for that reason. because then you'll remember those numbers. Otherwise, there's too many numbers to remember, which we don't want to do that. I want to show you geometry. It's very basic geometry, but it's geometry that's important. And it's going to come up from time to time in this class. So how do I find, based on just what we're looking at now, this area to the left of -3? Right, right. What we can say is that the whole area has got to be 1. So if we take 1 minus 0.997, you get left and right. Now we just want left, so we divide it by 2. So that is going to be 1 minus 0.997 divided by 2. Any questions so far? All right. So now we're ready to answer the question. If we want the area, if we want all the area to the left of 3, what do we do to those two numbers? Yeah, we add them up. And I'm going to do a little in my head. 1 minus 0.997 is 0.03, 0.003. And 0.003 over 2 is 0.0015. Half of 30 is 15. And then I'm going to add 0.997. And what I get is 0.9985. Any questions? Any questions at all on part B? Any questions? Okay, so you'll notice it takes some work. Doesn't just happen. Okay. I'm going to see if you guys can do this, and we'll see if this works or not. I am going to see if I can make this happen. I'm going to see, let's do a group chat, a group meeting kind of thing, smaller groups. And let's see if you can find, the probability that z is between -1 and 2. Let's type that in the chat in case you use it. So find the probability that z is between -1 and 2. And what I'm going to do, I have to stop share because I don't know how to do it without stopping share. And I'm going to send you into groups of 3 and see if you can answer this question. And in case, I'm not even sure if you can hear me, but I'm going to broadcast a message to everyone. Just to remind you, we want to find the probability that z is between -1 and 2. And do your best. And I'm here to help if you have any questions. Okay, so we're back. Hopefully that worked. And let me drop that one. And let's go back to share screen. Okay, so let me show you, let's go over this problem. And it looks like some of you had some really good ideas, and let's see if you got it right. So we want to find out the probability that we're between -1 and 2. Okay, so to find that probability, we draw a picture. Picture is really important. So -1 to 2. Let's draw a line. Got to have an x-axis. Got to have a normal curve. Something like so. And we want to go from -1 to 2. So -1 might be somewhere over here. Okay. If you've had calculus, it's called the inflection point. I'm not going there though, so don't worry about it. And then we're going to go 2, which is out here. We're going to find that area. Okay, so the first thing is it's always a good idea to draw what you need to go both sides. So I'm going to go not just -1, I'm going to draw 1 also. And I'm also going to draw -2. Because that's kind of what we know how to do. Okay, so I heard one group say, well, what we can do, let's type in these numbers. So in case you forget what I just said, that's -2, that's -1, that's 1, and that's 2. Any questions on the picture so far? And we want the area between -1 and 2. So it's kind of that area there, all that scribble stuff. All right, well, the problem is we don't have numbers that show exactly that, but we do know between -1 and 1. Between -1 and 1 is how much of the data? Yeah, that's 0.68. So what I can do is I can label that as 0.68. There we go. And what we need to know is we need to find out what this bit of data is between 1 and 2. And if we add those two, then we'll get between -1 and 2. Does everyone see that from the picture? So the idea, I know one group had this idea is, well, if we go -2 to 2 and subtract -1 to 1, that'll give us both the left and the right of these little wedges. We want half of that, so we divide by 2. So now let's go and do that. So that is going to be 0.95 minus 0.68 divided by 2. Any questions at all on the picture? Little symmetry piece. Okay, so now we just finish it off. So what we can say is this probability that -1 is less than z is less than 2 is going to be equal to 0.68 plus 0.95 minus 0.68 over 2. And I'm just going to pop that in the calculator. That's the easiest way. and I get 0.815. Any questions at all on this idea here? Okay. Don't memorize these answers. Okay, that's not helpful at all. What I want you to do is become familiar with what the picture is and how to manipulate the picture to get what you want, especially left area versus right area versus between area. Okay, because that's what we're going to be doing a lot of for the next bunch of weeks. Okay, the number 0.815 is worthless. 0.818, because they have one more decimal place. I'm not sure who the they is. I'm using 0.95 and 0.68. I'm doing what's called the empirical rule. So I'm going to use, again, the 68, 95, 99.7 rule. Does that make sense? So I'm going to keep it at that. Okay, and in fact, you could even say 82% and do just 2 decimal places, since it's all we have to start with. Okay. On the test on Thursday, I don't care. As long as you show your work, and as long as you know your ideas are correct, then you get full credit. So you don't have to worry about it on Thursday's test, and that's what really matters. Okay, this won't be on Thursday's test; it'll be on the exam 2, not exam 1. Okay, let's look at the z-score. Find the z, such that there's a 2.5% probability of being greater than this value z. So let's do this one. I'm going to do this one now. So 2.5% of being greater than that value. So let's draw. And it always starts exactly the same way. And that is, you draw a line, you draw the normal curve. I do my best. That's pretty good. Okay. And we want to say if there's a greater than, let me ask you, if it's greater than, I mean, if it's 2.5% chance of being greater than, or probability of being greater than a number, is that number large or small? Yeah, it's large, right? If only 2.5% of the people are taller than you, you're tall. Is that clear? So that means, I don't know what this number is, but at least I can do a little sketch and say it's something like that. Okay, and just like I've said multiple times now, we should always draw the symmetric picture. So I'm going to draw the other side also. Now what I could do is I can say that area there is 0.025. But it's a symmetric picture. So this area here is 0.025 also. Any questions at all on the picture so far? Okay, so let me ask you, what's the middle area? About 99.5. So if you look at the left and the right and add those up, what is 0.025 plus 0.025? Okay, so 0.025 plus 0.025 is 0.05. Is that clear? The full area is 1, so what is 1 minus 0.05? What do you get? I don't see y'all jumping in. This isn't that hard. It's just arithmetic. Could even use a calculator if you want, or a computer. Yeah, 0.95. Okay, well, that's important. So if that area is 0.95 in between, what do we know about this number, the x value or the z value on the right? What must the z value be if that area is 0.95? And this comes right from the empirical rule. So we're able to read the answer. Yeah, it's just a 2, because that's what the empirical rule says, is that we always get 2 standard deviations, or a z of 2, if the area is 95% in between, -2 and 2. So the answer is z is 2. Any questions on that? Any questions? Okay, I'm not going to do all these others because I only have so much time. But let's try with calculator now. Okay, and I'm going to use a computer. So now use your calculator, and I'm saying computer calculator. Suppose that x follows a normal distribution with mean 2.14 and standard deviation 23. So the first thing I like to do is just write down x tilde n 114, comma 23. And I will let you know on exam 2 and also the quiz, I'm going to ask you to write the distribution. If I say write the distribution, you write x, you write a tilde, and you write an n. Okay, and then by the way, next week, the x is going to change. But the tilde n is going to stay. Then you write the mean, comma, the standard deviation. Okay, any questions so far? Okay, so let's do some of these. So let's find the probability that x is between 100 and 120. So let me write this down so I don't lose it. X tilde n 114, comma 23. And we want the probability that x is between 100 and 120. All right, so what I'm going to do is now we're supposed to use our computer. I'm going to show you what I did, and I programmed this. Okay, and this is one of those where just let it be. But this reason I did this is, I don't know if you remember, but when you go to the quiz for the advanced quiz stuff, there's this screen, and you're going to be responsible for knowing which link to hit. Which link should we hit? Something between 1 and 24. And the hint is they're in the order of the class, and we're not that far into the class yet. So it's not anywhere, way high. What link number? Yeah, link number 7, normal probability. Notice we've already done expected value, binomial probability. Now we're on normal probability. So let's do a normal probability. And the way I programmed it is I ask you for the low. The low in this case was 100, because x has to be greater than 100. The high in this case was 120. The mean was 114, and the standard deviation was 23. Okay, and by the way, I coded this so that you leave one of these blank, it'll find it if you have everything else typed in. And now I hit calculate, and there's our probability. Let's go, I don't know, 4 decimals, 0.3315. Any questions on that? Okay, let me do the following, just so you have it now. Okay, I just put the link in the chat box so that you can get to this calculator. Okay, this particular one. All right, let's see if you can find the probability that X is greater than 200. Give you a minute or so, and you will need a calculator. There's no way in the world you can do this by hand. Don't even think about it. Okay, without that calculator, and try using the one that I wrote, because that's what you get on quizzes and stuff. So I gave you the link, and then you can go find that probability. And let's see what you get. So we want the probability that X is greater than 200. Okay, and we're still on a mean in 114 and a standard deviation of 23. Give you a minute. Again, you'll have to go to that link. When you've got it, if you can pop in the chat box, and let's see if you agree with others. This should only take a minute. Just type the numbers in and hit calculate. Okay, I'm seeing some 0.9999s. All right, maybe I'll go to it and we'll take a look. All right, if you're greater than 200, what's the lowest you could be? Basically. Yeah, 200. Okay, I want to let you know this is the normal distribution is a continuous distribution. So whether it says greater than or greater than or equal to makes no difference, because the probability of being equal to something is always 0. What's the high? If you're greater than 200, what's the highest you can be? Yeah, or even better, just throw a bunch of 9s in. Okay, you can't write NA, so you got to give a number. And here's my recommendation. I go 2 more digits than what's out here. So these are 3-digit numbers. So I'm going to do 5 9s. Mean and standard deviation are still going to be 114 and 23. I need to erase my probability because that's the one I want. And with this, you have to leave one empty and hit calculate. So I'm a little worried that some of you said 9999. It's actually 0.0000. It's very close to 0. Okay, it's 4 zeros and then a 9. Any questions? Ah, right. If you leave the high blank, then what it's going to do is it's going to fill in the high, which was 9999. Yeah, don't leave the high blank because you have to have a high. 0.00009 was what the calculator gave. One of the reasons why I'm showing you this is so you get used to this calculator. Every calculator has its things that you have to deal with when you're dealing with infinity, and that's how this one works, is just put a bunch of 9s in. By the way, the TI-84 has the same thing. Okay, you got to put a bunch of 9s in. Let's see if you can give me the probability that x is less than 90. Okay, and use the calculator. What's the probability that x is less than 90? Okay, and again, you can't do this in your head. That's not going to work. You have to actually work it out on the computer. And practice the computer because tests will be on the computer. Okay. Looks like you copied and pasted all those numbers, which is fine. Okay, so let's take a look. X is less than 90. So I'm going to go over here. So now, what is the low? What's the low? Zero, but actually, how about negative 9999? Could even be lower than zero. Negative numbers are allowed. Maybe one more 9. And then the high is 90. Yeah, they give the same answer, but you got to be careful because there'll be times when they don't. This example does, but you're better off doing a bunch of negatives, a bunch of negative 9s. Otherwise, sometimes you'll get the wrong answer. Leave P blank, and you get 0.1484 about. Any questions on that so far? Okay, let's do the next one. Next one's a little harder. Find the probability that x is greater than 105 given x is less than 125. So any suggestions on a strategy for this one? Because the calculator doesn't do givens like this. So any suggestions on this one? And here's a hint, is you definitely need chapter 3. Find P of 125. We're going to do that possibly, but we have more than that. Okay, so what we need to use is a formula, and that is the probability of A given B is equal to the probability of A divided by the probability of B. Probability of A and B divided by the probability of B. Well, if x is greater than 105 and less than 125, that means 105 is less than x, which is less than 125. Any questions so far? And then divided by the probability that x is less than 125. Any questions on this approach? Any questions? Okay. So the key on this one is we have 2 different probabilities and then we divide. So let's just do these separately. So probability that x is between 105 and 125, I go to my calculator. My low is 105. My high is 125. Same mean, same standard deviation. I need to blank out my P, so it'll give it to me. And then I hit calculate. And I get 0.33 So let's go back. And this is going to be 0.336 divided by, and now we find the probability that x is less than 125. So now I go back to my calculator. If I want to be less than 125, my low is negative a bunch of 9s. My high is 125. Same mean standard deviation. I blank out my p, and I hit calculate, and I get 0.6838. Any questions at all on how I'm doing this? Okay, then I'm going to pop it into just the standard Google calculator, and I get 0.4914. Any questions on this one? Okay, let's do the next one, and that is find the IQR. What is the IQR? Who remembers what that means to say IQR? And this is important because that's it in chapter 2. So that means you're being tested on Thursday. Yeah, that's the interquartile range, the middle 50%, and in particular, it's the third quartile minus the first quartile. Let me write that down. So that's the third quartile minus the first quartile. Any questions on this idea here? Q2 plus Q3. No, it's Q3 minus Q1. It's definitely not Q2 minus plus Q3. Yeah, it's Q3 minus Q1. Okay. So that's just a formula. That's nothing fancy. That's just a definition. So what does it mean to be the third quartile? What does that mean? So what does it mean to be the third quartile? '75th percentile, exactly. So now what I'm going to do is 75th percentile means the probability is 0.75 that we're below a number. Okay, well, we don't know the number, so that means we don't know the high. Being below the number means you can go all the way down to negative infinity or just negative 999, and I want the high. So what I do is I leave the high blank, and then I hit calculate, and that gives me 129.51. All right, I need to subtract the first quartile. So what changes if I want the first quartile? What changes if I want the first quartile? No, the low turns out to be the same. That's a good try. The low turns out to be the same. That doesn't change. If it's the first quartile. What's the definition of the first quartile? That's a hint. Remember, the third quartile was the 75th percentile. Yeah, so what changes is instead of 0.75, I'm going to have 0.25. And the high is what I want because that is the first quartile if P is 0.25. So I hit calculate and I get 98.49. Okay, now I can put that in my Google calculator. And I get 31.02. Any questions on that? Okay, I think I'm gonna go to the word problem now, or at least the first word problem. Fun little problem. Okay. So now, suppose that the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. By the way, this is not a math question, but hopefully you all know. What does it mean to say the mean is 140 days in this situation? What do you call that? This is not a math word. This is a pregnancy word. If we have any pre-nursing students here, you need to know what this is. It's not fancy. So everyone knows these words. 2 words. I don't see you jumping in. Maybe none of you have kids. Prenatal, good try. Should I tell you? It's your due date, right? When are you expecting? 140 days. Does that make sense? So that's what that is, because that's what the mean is. Mean is what you would expect, what your average, based on all the different, women that have been pregnant at that amount of pregnancy, how many days it's going to take. And they call that the due date, right? Okay. That's the when are you expecting, when's your due date. Standard deviations, interesting. It turns out, again, this is biology, not math, but it's kind of cool. It used to be 7 days, and it's not anymore. Anyone know why? Humans have changed. Anyone know why it's not anymore? I don't see y'all jumping in. Again, it's not a math question. Okay, it's not because of C-sections. Yeah, induced labor, there we go. Yeah, induced labor. Induced labor changed everything. So we're gonna pretend, I know it may not be right, but we're gonna pretend that we're not gonna allow induced labor because then it's not a normal distribution, but it used to be actually a normal distribution with a standard deviation of 7 days. So we're gonna go with that. Okay, now, here's the question. Your boss has just scheduled you or your wife for a business trip to China. And we're going to pretend that we're in normal times. There's no coronavirus or anything like that. So you're actually, flying is legal and all that kind of stuff. Okay. You or your wife leave today and return in 135 days. Find the probability your baby is going to be born in China. Any questions on the question? Okay, I'm going to give you a minute or two, see if you can do this. See if you can find this probability. Find the probability your baby will be born in China. You're going to be you're leaving now and you're returning in 135 days. And I'm going to give you a minute and then I'll do it, but it's always good for you to try first. And again, you do need the calculator. There's no way you can do this without it. If it helps, I'm going to write this down because it's something I want to emphasize. You should always write down. That is x tilde n 140, comma 7. So whenever you see a normal distribution, you always want to do this tilde n mean standard deviation. Okay. So I'm going to see if 2 people can get it, hopefully. Hopefully get the same answer, of course. By the way, in terms of number of decimals, Nobody in the universe would ever care about having however many that is, like 15 decimal places. Okay, probably 2 is just fine in this case. Does that make sense? Nobody cares about that many decimal places. It's not useful for anything in life. 2 or 3 decimal, maybe 4 at most. Okay, I wouldn't take off points, but I just want to give you a kind of, life skills. And that is, yeah, copy and paste is easy. That's true. Okay, let's see if other people get it. Okay, good. We got 2 people. Let's take a look. Okay, we have 147 and 135. So let's go ahead. And we don't know the probability, so I'm going to erase that. We know the mean is 140. We know the standard deviation was 7. Now the 135, what is that? Yeah, that's the high. And the low, you could either leave it at 99999. You could make it 0 if you want. It actually doesn't make any difference in this case. And then I hit calculate. And I get 0.2375. Okay, by the way, what do you think? Again, we're assuming we're in normal times. Coronavirus is over. Otherwise, it's just too hard to do this class with such craziness. Would you be okay with that? If you were pregnant or your spouse was expecting a baby, would you be okay to be in China and have a 23.75% chance? Okay, I hope not, by the way. Yeah, no, that'd be a really bad idea. Okay, so these are why we care about probabilities, because it actually gives you some reasoning. Hey, I'm not okay with it. Almost a fourth of a chance of having my baby in China. I want to be at home. Okay, so here's what we got. But you don't want to lose your job either. So here's part B. Part B is you decide it's too risky. Okay, so you're going to negotiate with your boss. And you're going to say, well, if it's no more than a 1% chance, I'll be all right with that. Does that sound reasonable? Okay. So what day should you ask your boss to be the return date? Any questions on the question? Okay. All right, so we got one suggestion. Let's see if we get another one. So what day should the return date be if you want to negotiate so that there's only a 1% chance that the baby's going to be born in China? Okay, we got 2 with the same answer. Let's see. Okay, so first thing is we don't know the high. That's the whole point. We're renegotiating. It's not 135 anymore. The probability, though, is 0.01. And then I hit calculate, and I'm looking at day. And again, you're negotiating. You always probably want to round low for negotiation. So 123 sounds like better. If your boss says 124, you might say, well, I don't know, that's risky. And then try and bring it back to 123. Any questions on that? Okay, let's do some more. Okay, it is now 138 days later, and the baby still has not been born. Okay, so you or your spouse is looking pretty big. Find the probability that the baby will be born within the next 24 hours. Okay, how do I do that? What's the strategy behind this? Okay, so the one thought was 138 for the low and 139 for the high, but actually we could do more than that. So let me tell you, we got to use the fact the baby hasn't been born yet. So this is actually the probability that X is between 138 less than X less than 139, given that X is greater than 138. Any questions on this strategy? This is a given problem. We have information the baby has not been born yet. Okay. Had we looked at part A and we just said what's the chance between 138 and 139, that wouldn't be a given problem. But the fact that it's now 138 days later, the baby still has not been born, that means this is a given problem. Any questions on that idea? All right, well, now we have a formula for given problems. Okay, by the way, if it's between 138 and 139, and you know that it's greater than 138, that's just the same as saying between 138. Sorry, if it's 138, between 138 and 139, and it's greater than 138, that's the same thing as just saying it's between 138 and 139. So that's equal to the probability that 138 is less than X, which is less than 139, divided by the probability that X is greater than 138. Any questions on that? So now we just compute these two, 138 to 139. So now the low is 138. The high is 139. We don't know the probability. Yeah, given is always has a formula of probability of A and B divided by the probability of B. That's just a formula for given. And that's the easiest whenever you have these kind of word problems. And by the way, that could happen on your test, so know how to do that. And hit calculate, and you get 0.05565. So let's just type that in. Then we're supposed to divide that by the probability we're greater than 138. So we don't know the probability yet. What changes if we're greater than 138? Which of these boxes change and what does it change to? Yeah, so what changes is the high now, put a bunch of 9s in. And now we can calculate and you get 0.6125. Any questions on that? And let's just do that. I'm going to pop it in my calculator. And you get 0.09 out. Here. Okay, or about a 9% chance baby's gonna be born in that within 24 hours. Any questions? Any questions on this application? I like this application because it's actually very realistic. Okay. By the way, if you ever have a baby, you'll probably never forget. You may forget the details, but you're like, how was that done again? Now I can start figuring it out because you just want to give birth or whatever. Okay. So these are the kind of things that actually are helpful. Or more importantly, let's say you're a doctor or a nurse or whatever, and you want to do consulting, you want to talk to your patients and talk about risks and what to expect and things like that. And these are ways of figuring things out. Any questions at all? Any questions at all on this example? Okay, let's do the very last one and then we'll talk about the test. Okay, I don't know if I'll do all of it, but we'll do some of it. We'll see how much time we have. Okay, suppose that, let's do this. Suppose the amount of ice cream that you sell each day. Okay, so you get an ice cream. We're going to pretend that you're allowed to sell ice cream. Things are so crazy now. So hopefully in the summer, maybe we can be back open and we can actually have an ice cream store. And let's suppose that the amount you sell each day is normally distributed with mean of 950 ounces and a standard deviation of 120 ounces. Okay, so the first thing you do before you even read anything else, it's always a good idea to write X tilde N 950 comma 120. And that way we have the information just loudly at us. Make life a lot easier for us. Find the probability that on a randomly selected day, you'll sell between 900 and 1,000 ounces. Let's see if you can do this. So I'm going to give you a shot. And again, if you don't have the calculator, you can't do this problem. Okay, we got one try. Let's see if someone else can agree or not agree. Okay, we got two pretty close to agreements. So we have 950, 120, 900, 1,000. So now we're going to go 900 for the low, 1,000 for the high, and then 950, I think. Let me double check. 950 and then 120. And then we have to make sure that our T is left blank. And we calculate. And you get 0.3231 if you do proper rounding. Any questions on that? Okay, I want to make a note, even though this particular stuff is not on the exam, but on an exam, you want to write a little bit about what you're doing so that if you make a mistake, like maybe you copy the number wrong out of the calculator, I can still give you a whole lot of points. Whereas if all you do is copy the number wrong and you don't explain what you did to get there, I can't give you anything if you copy the number wrong. So that's just a big suggestion, is make sure that on the exam, you show your work, okay? Of course, I'm doing it in a video, so you're all seeing it, but I can only see what's on that page that you submit. Okay, so now part B, in the morning, you took stock of your supplies and you notice that you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Let's see if you can answer that question. Okay, and again, the hint is it's not that hard if you know what to do. That's how most of these are. It's how this class is actually. What's the probability you're going to run out by the end of the day if you have 1,100 ounces of stock of ice cream in your store? Okay, we got one suggestion. Let's see if someone else agrees. I always like to see if we got a confirmation. Okay, let's take a look. Let's talk about it. Okay, first thing, the mean and standard deviation are the same. We want a probability. So I'm going to blank out the probability. What does it mean to run out? What does it mean about the demand? About the customer demand? Okay, Yeah, it means we have a high demand. In fact, if we have exactly 1100, we won't run out. But again, exactly is not a problem, but any demand higher than 1100, we run out. So if you want to find out the probability that we run out, that means our demand was greater than 1100. And when I hit calculate, I get about 10.56%. Yeah, so I'm not sure if we have any business majors here, but these are the kind of things you really have to understand with business, because this is a typical business question. So I decided in this class, a lot of times I have a lot of medical type majors, and I have a lot of business majors. So I try and do one of each if I can. Okay, now let's suppose you want to be 99% certain that you will not run out of ice cream. How much do you need to have in stock at the beginning of the day? So let's see if you can answer that question. And that'll be the last, and then we'll talk about the test. So let's see if you can answer this. So you want to be 99% certain that you're not going to run out of ice cream. Okay, in that one day. So how much do you need to have in stock? Let's see if you can tell me. Okay, we got one try. Let's see if we can get another one. Okay, I'm seeing a couple answers, so let's figure it out. Okay, so the first thing is I want to be 99% certain, so P is 0.99. That's a probability. Hopefully that you all got. Any questions so far? Okay, now what does it mean to not run out? That means, and again, so to not run out, we know the mean is 950, right? So let's write this out. To not run out means that our demand was low. We don't know what the high is, but we can call the low to be negative 99999. Any questions on that? And then we want to find out what is the high, and you hit calculate. And you get 1,229 about. And by the way, if we use 0, just to show you, it didn't change. Because we're talking about many, many, many standard deviations below the mean, and we already see 3 standard deviations is pretty much everything. So 0 works in this case. So 1229 is the answer. Any questions at all on the normal distribution? All right, so now what I'm going to do is I am going to stop talking about chapter 6. And now let's talk about the big thing that should be on your minds right now. Okay, the project's over. So that may be on your mind, like worrying about it, but in terms of working, not the project. What's the big thing that should be on your mind? Hopefully you all know. Yeah, the exam. So I want to mention a bunch of things. So let me go back to the syllabus. Okay, so let's look at, I'm going to mention a bunch of things. Okay, first thing is the date. Oh, sorry. How did that happen? Don't worry about exam 2. It's not February 27th. I don't know how that happened. I got to change that. The exam is April 30th for exam 1. And that's in 2 days. The exam will be at the regular time. Okay. For those who have a accommodations, then the start time will be the regular time, and then the end time will be later if there's disability accommodations. So that's just a note, is that that's how it works. The way I'm going to do it is I still want to welcome everyone at the beginning. So I'm going to have everyone log in to Zoom, say hi. Maybe if I find anything new or something, I can tell you about it, give you warnings, whatever. And then what you'll do is you'll log out of Zoom and you'll jump onto the exam. If you try and log on the exam now, you won't be able to get to it. It doesn't open until 1:05 on Thursday. And it closes at 3:25. So you're going to have 2 hours and 20 minutes. Any questions on that? Okay, that does not mean it's going to take you 2 hours and 20 minutes. It might, but it probably won't. Okay, I actually did the exam today. I always like to do the exam so I can fix any errors I find. I only found like really minor errors, a spelling error or something, but there could be others I missed, but I try not to. So any guess, how long do you think it took me? And that's showing all my work with full explanations. So there's a lot of typing for me. All right. It turns out one of you is right, 45 minutes. So it took 45 minutes for me to finish. That does not mean it's going to take you 45 minutes. I figure it'll take you an hour of thinking, 45 minutes of writing, typing, and then hour and 45 minutes is probably all it'll take most of you, something like that. Again, everyone works at different speeds. But, make sure that in your schedule, you plan to, have that available for the full 2 hours and 20 minutes. Can you use scratch paper? Here's the thing. I can't, if you use scratch paper, I can't see what you did on scratch paper. And what'll happen is I can't give you partial credit for it. Does that make sense? And so the problem with using scratch paper is that if you make a little mistake, I can't give you any credit, even though your thinking might have been right. Yeah, if that helps you, you can use scratch paper. Okay, what's going to happen? This is a Proctorio test, though. So you have to sit there the whole time. To give you a warning on that. So you better go to the bathroom first. Okay, so you're going to sit there the whole time. The first thing that's going to happen is it's going to have a camera at you. You're going to have to show around the room, and you're going to have to make sure that basically there's nothing there except your scratch paper. Any questions on that? So you're going to have to show your scratch paper on the screen. You're going to put it up there at the video and show the scratch paper. Does that make sense? Okay, so that's a note about the scratch paper. And again, I'm improvising. Honestly, this is the first one of these kind of tests in my life that I've ever given, and I've been teaching for over 30 years. This is not normal times. So I'm doing my best to figure it out. You could use scratch paper. You can also bring in a note card, 3" by 5" that has anything you want written on it. Okay, but you have to show it because you're gonna have to show around the room. You show the note card to Proctorio, and then you can put it down. What you cannot do is bring a cell phone, a smartphone. That needs to be outside of the room you're in, or far in the other corner that you can never get to. You can't have a second computer. All you can have is the one computer you're working on, and you're only allowed to use the screen that you're looking at. Okay, you can't have multiple tabs open or anything like that. All right, so the question was, I asked for the pros and cons of sampling. My guess is you meant the pros and cons of different sampling techniques. Is that what you're asking? Okay, because sampling is always a good thing, you know, if you're doing statistics. So sampling technique, yeah, I'm not going to say I will, but it's a possibility. So I will tell you that everything from day 1 of class through the lecture on Thursday and the quiz today is fair game for this test. Got it? So that's all fair game. What I can't make you do, but this is what you can do on your scratch paper, is I can't make you draw pictures because that's just way too hard in Canvas. But you can do a picture on scratch paper and then describe the picture in words. That I could do. I could say, describe the picture you have to do. Okay? Because drawing of pictures is not something you can do in Canvas. Any questions on that? Okay, the other thing is, just like the quiz that you had last week, remember there was an embedded calculator on that? Did that work for you? That was my first time ever doing this. Did that embedded calculator work? Given that you knew how to do the problem at least. Were there any technology problems with the calculator? Okay, so you're going to have that same embedded calculator on every problem that is possible. Yeah, the bulky thing I can't do anything about, unfortunately. The problem is that the way LibreText works, which is what I put this on, it's got all kinds of other stuff behind besides the calculator. So I can't just say focus on this piece. Sorry about that. Yeah, that was one I like banged my head against and realized there was just no way. Sorry about that. So it is bulky, but again, you should have it's 2 hours, 20 minutes. There should be enough time to kind of handle the bulk. Okay, but practice with your embedded calculator. So you're not allowed to use any other kind of calculator. You can't use a T84 because that looks too much like a smartphone, and Proctorio will like zap you and say, oh, this person just used their smartphone. Do you see what I mean? So use the embedded calculator, but it does everything you need. Okay, I purposely programmed it so it does what you need. The only thing it doesn't do, which is a pain in the butt, is arithmetic. So you have 2 choices. One is you can leave the arithmetic as goes or just approximate. The other is supposedly there's a calculator available in Proctorio. The bad news is I don't have the ability to test it because only students can test it and I'm not a student. So I'm hoping it works, but I won't know until you tell me. Sorry about that. But here's something I did do. I created a quiz today. And this quiz, if we go to the syllabus, I think I made it due on Thursday. You'll see there's a quiz called Practice with Proctorio. Right, so this is what I'm about to say. Supposedly the quiz, when you go to Proctorio, there is a calculator embedded in Proctorio. Okay, so I created a quiz so you can practice. Unfortunately, I can't see it as a student. I can't see it embedded. I can hit preview, but it won't show the Proctorio thing. As you'll see, it says, however, the exam's proctored, you have to get the full exam, you have to be a student. Okay, the quiz doesn't have anything on it, just let you know. So all this is, I had to put one question on to make it a real quiz, And all it says is, this is just a practice. Is it working? True or false? But supposedly you should be able to get into a calculator from that. And Proctorio is supposed to give you one. Unfortunately, I can't test it. So maybe you could test it and see. And it should be a scientific calculator. Does that make sense? So Proctorio is supposed to have one, but I can't tell you what it looks like because I don't have access. Only you do as students. So again, I created this practice with Proctorio so that you can see the calculator and see how it works. Does that make sense? Okay, and hopefully it'll work, but you have to let me know. Okay, and make sure that and this also helps you practice to make sure that your webcam is working and your, and your microphone and all that. Okay, and I made it because I had to make it worth points. You'll notice this is worth, I think you can't see it. Let me go here. This is worth 0.01 points. That's the minimum number of points I can make anything worth, which is basically no points. Okay, so don't get scared if you lose, 0.01 points in the class on the quiz grade because it means nothing. Okay, a question tends to be 10 points, so it's 1/1000th of a question in one quiz, so it's nothing. Any questions on that? Okay, so again, I apologize for not knowing what the calculator looks like, but I can't test it. So I don't know, I can't even see it, but you should be able to. And you can by doing this practice with Proctorio. And I have this going until Thursday, I think, and you get to practice once. And if it doesn't work for you, I can set it again so you can try again, but you have to let me know, send me an email or something. I can do it again. Okay, any questions on this little practice thing that I did? Okay, again, I am new. I am new to this Proctorio thing. So it's what I can do. Okay, so now I'm gonna unshare my desktop because I don't want you to see what I'm looking at. So now I'm gonna look at the test. And I want to talk about the test, but I'm gonna talk about the test by looking at the test without you looking at it. So you shouldn't be looking at the test. And this is, again, this is a first for me. So hopefully it'll all work out. I've been teaching for, longer than probably all of you have been alive, but that doesn't matter because we've never done this before. Let me find it. Just that one. So at this point, you're not supposed to see my screen. I think you can't, right? Let me double check. Yeah, you shouldn't be able to see my screen. So I'm going to describe a little bit. Minimize. I'm going to change my screen around a bit. So the question is, will today's lecture be on the exam? The answer is the only part that's on the exam was a quiz that you took at the beginning. Is that chapter 5 is on the exam, but none of the material, and I don't want to say it's not on the exam, but it's not on exam 1. So it is on exam 2, but exam 1 will not have the normal distribution probabilities. That won't be on exam 1. So hopefully that answers your question. And again, this is the whole point of webinars. Please ask questions if you have them. This is not some static video. So let me grab that test that you can't see so I can describe it. Okay. Okay. Someone says you have to click on the Proctorio settings tab, scroll down to in quiz tools and add the calculator and then click save. So if that worked for you, that's how to do it. Again, I've never done it. I don't know because I can't see it. This is something that you're going to know more than I am. which is kind of weird in this class, but that's how it is because this is a. So I trust you. So hopefully everyone heard that and everyone read that. Okay, so let me talk about the real exam. And the real exam, it has a lot of questions, but some are very short and not that many points. Let me read the first problem for you, because this you have to do. Okay, and that is write your name below if you agree to not communicate with any adult and not use any other devices or materials for this exam that have not already been expressly allowed by your instructor. So this is a signature, basically, you do that by typing. And this says that you promise not to cheat. Okay, that's number one. Okay, any questions on number one? Again, there's no math there, but that's important that you have to be able to do that. Okay, let me tell you number 2, number 3, number 4, number 5, number 6, and number 7. They all have the same first sentence, and that is answer the following true or false. Okay, so answer the following true or false. Choices are false and true. And I don't know why, but for some reason there's 2 buttons. Don't click the bottom ones because those are nothings. Either going to be false or true or false, and it randomizes whether it's false or true. I mean, randomizes which is read first. Okay. So just to note, do not leave it blank. How come? Give me some probability reasons. If you leave it blank, what's the probability that it's right? 0. If you have no idea and you guess, what's the probability that you're right? Yeah. So again, you have basically, if you leave one of the true falses blank, you have proven to me that you don't even know the very basics of probability. 0 versus 0.5. So, but hopefully it's going to be a lot higher than 0.5 because you'll have studied a whole lot and you're going to be able to read the true false and say, yeah, that's why. Because I know that definition of that word and I know how that works. I know that concept. Okay. I will let you know that the true false questions are often the hardest questions on the test in terms of, getting it right. Because they ask you not to compute things. They ask you for ideas. And ideas are harder in statistics. So I want to give you a warning. They don't come straight for the homework. Okay, I made them up. I wrote this on Sunday. So I made them all up on Sunday. Okay. Okay. And by the way, don't be too surprised if your name might be in one of these. Just let you know. Just for fun. I do that at quizzes and that. Okay, so then after that, there's again a bunch of these. Then after that, there are 3 multiple choice questions. And those are also idea questions. You have to understand the vocabulary that we've done in class. And we've done a lot. So maybe you could type in the chat box. What vocabulary words have we had in the last 3 weeks, in the first 3 weeks class? There's been a bunch. So maybe each of you can at least type 1 or 2 words. So what are some of the statistical vocabulary? Statistics words. Okay, probability is 1. Good. Mean, standard deviation, median, IQR. Okay, those are a bunch. Those are good ones. Okay, let me throw some more at you. How about stratified, cluster, random, systematic, convenience? Remember those words? How about quantitative, qualitative, discrete, continuous? Remember those words? How about box, stem, and leaf? There's a lot of vocabulary words we've had in the class, and you have to really understand that, and you should also understand processes. Okay, then after that, the next question is going to be one with an embedded calculator. Okay, it's going to have an embedded calculator, and it's going to have you do some calculations. And what you really want to do is don't just write down what your calculator gave you, write down what you put in your calculator and your thought processes. Because if you do that, then you can get partial credit even if your answer is not right. If all you have is a number and it's wrong, I can't give you any points.
Larry, I didn't really understand what you said right now, like the past 10 seconds.
One more time, you kind of choppy tap voice. Your mic's not good. One more time. You didn't understand about the test or something? There's some mic issues, so I can't really hear you. I got that I didn't understand about the okay, can't hear. I'm trying to keep my head in the same spot. So sorry if my mic's not perfect either. Okay, so the next question uses a calculator. Okay, and it's the embedded calculator, so one we've been using for the last couple of weeks. Yeah, sorry if it makes a tapping sound. I don't know if there's anything I can do about that. I think that's internet issues, and I can't fix it, unfortunately. Sorry. So you can always email me or post on the Q&A forum if you have questions. So just a note, the next one is a calculator thing. You're gonna have to do some stuff that we do in calculators. I'm not gonna tell you exactly what I'm gonna have you do. And then the next one is another one. It has an embedded calculator and you have to do some computations. And similar to the next one. Okay. And things that I'm trying to give you problems from each of the chapters. So they're all going to happen. Okay. So just let you know, you're going to have questions. You're going to have questions from 1 and 2 that are mostly vocabulary type questions. That's kind of the beginning stuff. Chapter 3 is that those are probability questions. You're going to have to compute the probabilities. Chapter 4 are very standard. Okay, expect binomial distribution, expect an expected value standard deviation kind of problem, and expect to be asked to interpret the expected value. Got it? So hopefully my mic is working and you can hear what I just said. Okay, for chapter 4, there's a couple different things. Expect to have to do a uniform distribution by looking at the area of a rectangle. Expect to be able to do the area of a rectangle's probability and expect to go backwards. Given the probability, find a value, find the left or the right for the rectangle. And also expect to use the mean and standard deviation formulas for uniform distribution. Very standard problems. Okay, and there's a couple of problems on charts where you have to know how to read charts well and maybe compute probabilities from the charts and definitely talk about statistics and stuff like that. And then there's a very last question, which I give in every one of the classes that I ever teach forever. And that says the following: it's extra credit. It's the only chance in the entire class you can get extra credit. And it is write down one thing your instructor can do to make the class better and one thing that you feel the instructor should continue doing. Any constructive remarks will be worth full credit. Do not leave that blank, because I can't give you points if you leave it blank, and I give you some points if you don't. Okay, right now it says 1 point, but that's going to change. And what I do is I look to see how the class is done, to see if you're working hard, then I give more points for the whole class. If the class is kind of like not doing their homework, then it's fewer points. So I kind of judge it by how much work the entire course, all of you combined are doing, not individually. Okay, and then I adjust, and then I make it consistent on points. Either sometimes I make up one of the problems that you got wrong and give you that number of points. Sometimes I just give you a fixed number of points. if you don't leave it blank and you say you write something in, there's only one way to not get points. Any guess? And the hint is you hope for this. It would make your day. There's only one way to not get points on that extra credit if you fill something in. Now, if you fill it in, if you type something. Okay, should I tell you? No, you could say all kinds of great things about me. That's not going to change anything. No, that's if you get 100% on everything else. Because I don't give more than 100% because statistically that shouldn't happen. But I would not assume that you got everything perfect on the test and just say, oh, I don't need to do this one. Because there's always, even I make little mistakes, you know, when I'm working it out when I do the key. You know, little mistakes could happen. So, you know, don't leave it blank. Okay. Very, very rare does anyone get 100% on everything else because there's 16 different questions to do. All right, so that's about it. I'm gonna stop the recording.